All right. So now that we've talked about in depth all of this stuff about our sign functions, we talked about the formula, we talked about what A, B, C, and D do in terms of both graphical visual transformations and how we cause those transformations to happen in a table of values with our X and Y coordinates, with our domain and range. We talked about how we are going to have to think about our order of operations in reverse when we are transforming the domain, the X coordinates on our table. And then we kind of walked through a full example in terms of transforming the values in the table here. Now what we're ready to do is we're ready to go full bore into these problems where we kind of finish the full cycle here of equation to table to graph to characteristics. But before we do that, let's just take a quick look at the parent function, just so we have an understanding of what it is we're starting from when we perform these transformations. You can see I've kind of color coordinated everything already here for you, but some of the important things to point out that the absolute max and min for the parent function are 1 and -1, which means our amplitude, you can see, is 1. So that's where this A value, as A changes, that's going to be stretching or shrinking these absolute max and mins and amplitudes. All right. We see that also affects the range because the values of the range are also the values that are the absolute max and min. The period is affected by B. You can see the period here goes from -pi to +pi. Well, if I stretch that, I'm making the period longer, and if I shrink that, I'm making the period shorter. So that's why the B value here has an impact on the period. Notice my zeros, my X-intercept and Y-intercept are right on the origin at 0, 0. So that means I can start describing my X-intercepts at 0, adding pi, because that's how far it takes to get from one X-intercept to another X-intercept, plus or minus pi n, comma 0, and I can also use 0, 0 as the Y-intercept. One last thing here is that the D value is 0, right? Which means we haven't shifted up or down, which means the midline is Y equals 0, which means it's right on the X-axis. So as A, B, C, and D change, visually, this is the graph that we are changing, we are transforming. This is the starting point on which we're building off of everything. So take a look at this, make sure these characteristics make sense. If you have any questions about how I came up with the numbers here, please ask. It's not going to be, you can still do the work on these problems here on 1 through 5 and in the homework without understanding everything here perfectly. But I think if we understand what we're starting with, it's going to make a lot more sense, and we're going to be able to identify mistakes in our work a lot easier when we start looking at the graphs of our transformed functions. All right, so let's dive right in here to number 1. So what we have is, oh, you know what? I realized I'm going to have to go back and change all of these notes for next year, guys, but I apologize. These, let me just, and we're going to probably only do 2. I'll fix the other ones. But this should not be f of x. F of x is the parent function. G of x is what we are actually trying to graph here. So I apologize for that notation error. That actually should be pretty confusing if you look at the table. So we're graphing the transformations, the sign functions from the table, and then also putting these values here. And I guess I should state here for you that f of x equals sine of x. In other words, that's the parent function. All right. So first deal, as always, as we saw before, is what's A, what's B, what's C, what's D. We've got to know those values that control both visual and graphic transformations, but also definitely control the transformations on our table. So we can see that A is now 1. That's a change, right? We can see that B, though, B is 1. Or, I'm sorry, guys. I'm getting my A's and B's mixed up. A is not 1. A is 3. B is 1, which is not a change. C is 0, not a change. But D, and I'll shrink these down here, is now 4, which is a change. So here's the deal. We are going to have to worry about transformations with A and D because they changed from the parent function. Just in case you want to see it here in the parent function, guys, and we talked about this on the previous page, right? In the parent function, those are the values of A, B, C, and D. So you can see since B didn't change, we don't have to worry about doing anything with B. Now, I'll probably still use the 1 over there, but you're going to see that it doesn't change anything. And same thing with C. The most important, well, really, what drives the transformations in this example is A and D. All right. So once we know that A and D affect the range, affect the y coordinates, and we follow order of operations, the normal order of operations. So we are going to multiply by A, which means we're going to multiply by 3. And since D is positive, we're going to add D or add 4. So each of these y coordinates needs to be multiplied by 3 and then increased by 4. So 0 times 3 is 0 plus 4 is 4. That's going to be 7, 4, 1, and 4. So we just now performed a vertical stretch and a vertical translation of those points. Just so you can see, guys, why we don't worry about these when they don't change from the parent function. Now remember, it's the reverse order. So we add first, and since C is 0, we're going to add 0, and then we're going to multiply by 1. Well, what's 0 plus 0? 0. 0 times 1 is just 0. What's pi over 2 plus 0? Pi over 2. What's pi over 2 plus 1 is just pi over 2. So what you can see, guys, is because there was no change in B and C, the x coordinates of the domain didn't change at all. So this one's kind of nice for the domain. We don't really have to worry about that. In the answer key, guys, I think I did this every time so you could get used to seeing the difference between the normal order of operations with the range and the reverse order of operations with the domain. All right, so let's come to our graph now. And now our first point, our y-intercept, is going to be 0, 4. Now, this is where we've got to do a little bit of work. Pi over 2 is not marked here, but pi over 2 is half of pi. Well, if this right here is 0 and this is pi, halfway between would be pi over 2. So 10, 9, 8, 7 right here. Now, I will say, guys, these graphs can be a little tricky to read because these last numbers are in between the mark where they should actually be. So when we talk about pi over 2, one thing to think about here, and we couldn't go and do this on everyone, but 2 pi here is actually right here on this edge. And the same thing with negative 2 pi, and this applies to the 10 and the negative 10. That's a little easier because you can actually count the tick marks, 10 and negative 10, and that makes a little bit more sense to us. So, but just be aware that 10 is actually the very edge here. So 10, 9, 8, 7. All right. So then we're going to come back down to 4 pi comma 4. 3 pi over 2 is halfway between pi and 2 pi, so right here. And we're going to drop down to 1, all right? And then, did I graph that correctly? Yeah, that's good. And then we're going to come back up here for pi. All right, now what this is, guys, this is just one period. What I always like to do is I like to fit at least 2 periods in. So I've repeated this pattern here. I went up, down, started at 4, up to 7, down to 4, down to 1, up to 4. So I can kind of repeat that pattern here over in this sequence. So if I'm going up to 7 here, that means I had to be coming from 1 halfway, then back up to 4. Oops, hold on. Sorry, guys. Connection restored. There we go. Back up to 4, then up to 7, and back down to 4. So you can see by kind of in this point here would be both the end of this green period and the beginning of this red period. So you can see I kind of was able to just kind of continue this pattern of points that I got from those first 5 red points. And then what we want to do is we want to graph this with a smooth curve. All right, and this might take a little bit of practice to get as good as me at graphing the trig functions. And if you're thinking to yourself, Mr. Dahl, are you proud? I'm bragging about your skills of graphing a trigonometric sine function. Yes, I am, and it is a little sad. All right, amplitude. Let's talk about amplitude. Amplitude we know is based on A. Since A equals 3, we want the absolute value of A, which is also 3. So our amplitude, guys, is 3. Right? Pretty straightforward there. Yep, that's what we got. Period. Let's talk about our period here. So how long does this take to repeat? Well, we could look at the graph, or we also know our period, guys, is 2 pi over b. Well, our b value was 1, right? So that's 2 pi over 1, which means our value is just 2 pi. Midline. Now, this is where we definitely changed. Midline is y equals d, right? Y equals d. Well, guys, d is equal to 4, so our midline is going to be y equals 4. And guys, that kind of makes sense. Look right here. You can kind of see that what we've done is taken these points that in the parent function were, oops, sorry, whoop, nope, no, sorry, hold on, guys. There we go. Those same points, these points here that are on y equals 4, were the points that were chilling on the x-axis right here in this example. All right, so there we go. We've got a table of values. We've got a graph with more than one period there graphed, and then we've got the characteristics, the amplitude, period, and midline correctly described there. Let's take a look at 2. Let's do one more together in the video. The other 3 I will do in the notes, so you'll have a filled-in answer key for the problems and notes, and I'll leave you to work on those on your own there. So what do we got here? We got A is 1. Notice my A value is 1. B is now 2. All right, C is still 0, still nothing on this one here, but D is now -3. All right, so again, in this situation, A didn't change. We don't have to worry about A, and C didn't change, but B and D did indeed change there. So we are going to have to work with those transformations. Now, D affects the range. So down here, we're going to multiply by A, which is 1, and then subtract 3. So -3, -2, -3, -4, -3. Up here, we're going to add 0 first, which, because that's the C value of 0. And then here's the key. Here's what we've got to remember. We are multiplying by the inverse of B. So if B is 2, we are going to multiply by 1/2. If B is bigger than 1, we're actually shrinking. We're getting smaller. So 0, that's going to stay 0. That's kind of nice. But 1/2 times pi over 2 is actually going to give us pi over 4. And pi times 1/2 will become pi over 2. Everything's getting cut in half. What's half of 3 pi over 2? Well, it's 3 pi over 4. And then half of 2 pi is just pi. All right. So again, all I did was multiply, add 0 to each of these, and then multiply each of these by 1/2. So let's come to our graph now. And we're going to be at 0, -3. Right now, this is where it takes a little bit of work here. If here is 0 and here is pi, notice each there's 4 units, 4 boxes between 0 and pi, which means each of these is a quarter of pi. So when we look here and see pi over 4, that's 1/4 of pi. We go up to -2 right here. This is our point, pi over 2, -2. Then we go back down to -4. Then we go down to 3/4. So 3 of these quarters, 3 boxes to pi, and then back up to pi. And there's one full period there. All right, so I'm just going to repeat that period right here. I go up, I go back down, I go down, and I go back up. Right, and that point right there is both the beginning of the green period and the end of the red period. And guys, I mean, you could keep going if your OCD is making you want to graph this all the way across. Go right ahead. I don't think that's a good use of our time necessarily. If you can show me 2 periods, if you can show yourself 2 periods, you kind of really can understand what's going on, and you'll be in good shape there. All right, so there's our graph. Notice very different than the graph we had previously. Right, that looks very different there, a very different transformation. So again, amplitude is based on A. We see A is 1. Absolute value of 1 is just 1. No worries here. Period. Now this is where our period's going to change. All right, 2 pi over B, absolute value, which is 2. Well, the 2's cancel, and what we're left with is pi. So my period now is pi. So instead of repeating that pattern every 2 pi radians on the x-axis, we're going to repeat it every pi radians. And that makes sense. Notice, look, the red points from 0 to pi, and the green points pi to 2 pi. It repeats every pi units, rather than up here, it took 2 pi units to get back to a point that it would repeat. midline. We still base that on D. We know D is equal to -3. So since D is equal to -3, that means my midline is y equals -3, which makes sense because these points that are on -3 used to be on the x-axis, and we shifted them down 3 units. All right, so there's our video on actually applying all this stuff. And guys, there are some details we're leaving out in terms of really the depth of understanding of, and one big question you might be asking is, why in the world are the x-axis in radians? Why can't they just use normal numbers on the x-axis? And there actually is a really good reason for that, guys, and it does connect to the unit circle that we talked about here in Target 2. And if we were in class, I would actually do an activity to kind of demonstrate to you how the unit circle, these values, these kind of x and y values on the unit circle and the angle measures of the unit circle actually are connecting directly to these coordinate planes. Unfortunately, we don't have we don't have the bandwidth to do that while we're e-learning. So you're just going to have to take my word for it that you're going to see the x-axis for almost every sine and cosine function is going to be written in radians, and we've just got to get used to and work on our abilities with fractions and working with things in terms of radians using that symbol pi. All right, so that's what we got. Give it a try. Let's do some practice. If you got questions, you know where to find me on the interweb, and I'll be happy to help you out.